Hello students, in our DME class we were discussing couplings and we have covered introduction, types and design of sleeve or muff coupling, design of split muff coupling and so on. So today we will discuss the design of flange coupling. In the design of flange coupling, first of all you have to understand the construction of the flange coupling. So let's see this diagram. So you know that coupling is used to connect two shafts. So this shaft is on the left side and this shaft is on the right side. You have to join them at this point. So what you will do, you will use an arrangement which is called a flange coupling. How to use this arrangement? First of all, you will use a key and a hub. This portion represents hub. It is written over here. This is hub and this portion is your flange. It is written over here. That is flange. So you have two arrangement, that is flange and hub. So these flanges are connected to each other by means of bolts. These bolts, if you see it from the side, are arranged in a circular pattern. Small d is the diameter of the shaft. Capital D is the diameter of the hub, which is taken as 2d. D1 is the pitch circle diameter of the bolts, that is taken as 3d. D2 is the diameter of the flange, outside diameter of the flange, and it is taken as 4d. This L represents the length of the hub, which is taken as 1.5d, and TF represents thickness of the flange. So before designing, you should understand all the parameters of the flange coupling. Also, I want to tell you that this coupling is unprotected type flange coupling. Unprotected. Unprotected means this is not protected because the heads of nut and bolt are exposed. Whenever a worker is going to work near this coupling and this coupling will rotate at high speed, his cloth or something else may got stuck in the heads of nut and bolt, which may cause an accident. So this diagram represents a coupling which is unprotected. There are also couplings which are protected type, and in those couplings there is a covering which protects the heads of nut and bolt from getting stuck in anybody's clothes. So that one is also called protected type coupling. So the design of both couplings are same but with a little difference in the end. I will discuss with you in the upcoming slides. So first of all, how will you design the coupling? Small d is the diameter of the shaft, capital D is the diameter of the hub, we have discussed in the diagram. D1 is the diameter of the bolt, capital D1 is the diameter of the bolt circle, that means pitch circle dia. N is the number of bolts, TF is the thickness of the flange, tau represents shear stress for the shaft, shear stress for the bolt, shear stress for the key. S represents shaft, B represents bolt, K represents key. Tau C represents shear stress for the cast iron because your hub and flange are made of cast iron. Sigma C represents crushing stress. Sigma CB is the crushing stress for the bolt and sigma CK is the crushing stress for the key. Now this table represents the number of bolts that you can use according to the given given diameter of the shaft. Means if your shaft die is 40 mm you will use 4 bolts, if your shaft die is 60 mm you will use 6 bolt, and so on. So how will you solve the question? Very important one. Design a cast iron protected type flange coupling to transmit 15 kilowatt at 900 rpm from an electric motor to a compressor. So you have to supply the power from motor to compressor. The power is 15 kilowatt and rpm is 900 rpm. The service factor is 1.35 and the following permissible stresses may be used. Shear stress for the shaft, bolt and key is 40 megapascal. Crushing stress for the bolt and key is 80 megapascal. Shear stress for the cast iron 8. Also you have to draw the neat sketch for the coupling. So first of all you will write the given data, the important data. From the power and rpm you will always calculate the torque. So first of all you have to design the hub, but before designing the hub you have to find the diameter of the shaft, that is small d. How will you calculate the diameter of the shaft? As you have done in the previous couplings like muff coupling or split muff coupling, the same procedure will be followed. First of all, that is torque is P into 60 by 2 pi n. P is power, that is 15 kilowatt into 60 by 2 pi n. you put the values and get the torque 159.13 Newton meter. And the service factor is also given. The application of service factor is that you multiply it with the calculated torque and get the maximum torque, and you will get as 215 Newton meter, or you convert it into Newton mm. This torque is always equal to pi by 16 tau d cube to calculate the diameter of the shaft. So put the value of torque here, pi 215 into 10 raised to power 3 pi by 16 tau shear stress for the shaft, and d is the diameter of the shaft. You will get the diameter of the shaft as 30.1, or we can say we can standardize this dia like 35 mm, because shafts are available in sizes 30, 35, 40, 45, 50, 55, etc. So we know that outer diameter of the hub is 2 times the diameter of the shaft. So outer diameter of the hub will be 70. And also the length of the hub is 1.5 d. So 1.5 into d, you will get 52.5 mm will be the length of the hub. Now you have to check the design for the hub, that whether your design is safe or not. How will you check the design? You check the shear stress for the cast iron and the given value of the shear stress for the cast iron. Your calculated value should be less than the given value of the shear stress. For this, we will consider the hub as a hollow shaft and apply the formula for torque for a hollow shaft. That is 215, that is torque is pi by 16 tau d4 minus d4 by d. Just put the values of outside dia and shaft dia, and you will get the tau c value, that is shear stress for the cast iron, and it is 3.4 megapascal. So since this 3.4 megapascal, which is calculated value, is less than the given value, which is 8 megapascal, therefore your design of hub is safe. Now in the next step, you will design the key. Your key design will be same as we have done in the numericals for the key. First of all, according to the diameter of the shaft, select the width of the key, or you can divide diameter of the shaft by 4 to get the width of the key. Now crushing stress is twice the shear stress. Crushing stress is 80, shear stress is 40 given in the question. Therefore you will use a square key, that is thickness and width are equal, that is 12 mm. Now what is the length of the key? Length of the key will be taken equal to the length of the hub, that is 52.5. So now how to check the design for the key? You have to consider the key under crushing and shearing. So first of all, consider the key under shearing. Apply the formula torque is equal to length into width into shear stress into d by 2. Put the values of torque, length, width and d by 2. Get the value of shear stress for the key, and its value is 19.5 and the given value is 40. So your calculated value is less than the given value. So therefore your design is safe. But we also check the crushing stress for the key. Apply the formula for torque, that is length into T by 2 into sigma C into D by 2. Put the value of torque, length, thickness and D by 2. Get the value of crushing stress for the key and you will get it 39. And this value is less than the given value, which is 80. So therefore your design of key is safe. Now in the third step, you will calculate or you will design the flange. First of all, the thickness of the flange is taken as half of D. So TF thickness of the flange is half of D, half of 35, that is 17.5. Now we have to check the design for the flange. How will you check it? We apply the formula for the torque is equal to pi d square upon 2 tau c into TF. So this is the formula you will use to check the design for the flange. Put the value of the torque and diameters and TF thickness of the flange. You will get the shear stress for the cast iron. You calculate it as 1.6 megapascal, but the given value is 8 megapascal. So your design of flange is safe. This slide covers the design for the bolts. This design for the bolts is the last step in this numerical, but we will discuss in the next part of the video. So stay tuned guys. Thank you.